gave you this formula yesterday, but really the equations were not necessarily in this format because we didn't really have any that had parentheses. And so we're just going to have parentheses in these today. And that A value, whatever's in front of the parentheses, that'll help you with that pattern we talked about yesterday, the 1, 3, 5, so you don't have to make a table. And if you remember the 1, 3, 5, and then we could continue like 7, 9, those are the differences between the perfect squares. So that's why I keep using that pattern as like a little cheat to graph. It's not a slope, but that pattern can help you find points really quickly on any quadratic graph. Now, in this format, you're going to see this today. The H and K is going to be the vertex of your parabola. So we got to find that point, and then from that point we can use the pattern to get more points on the graph. And the thing that's similar for absolute values when we did this, whatever the H, like in the parentheses, whatever that looks like, it's going to be the opposite of what that looks like, will be the x coordinate of the vertex. And then K, we're going to copy that, and that number will be the y coordinate of the vertex. So when you look at the formula, opposite copy, it's just like an absolute value. We'll do eventually square roots and stuff like that. They all have that same little trick, if you will. Whatever it looks like inside with the x, the operation here is to square it, but whatever it looks like inside, you can write the opposite of that. Whatever is outside, added or subtracted, we're going to copy that number. The inside number shifts the graph left and right. The outside number shifts the graph up or down, just off the origin. Okay, let me write this on this first one here. So do you get the parentheses exist, right? But there's nothing written in front of this. But the A value has to be 1, because if it was 0, then we wouldn't have a set of parentheses because we'd be multiplying by 0. But if the A value is 1, you might not see a number written out in front of that. So that's important for that pattern. So I know once I find my vertex, we can just do that 1, 3, 5 that we did yesterday. And I'll remind you how to do it again because I know a bunch of people were absent yesterday. Okay, so for my vertex, literally inside with the x, just write down the opposite of what that looks like. So to me that looks like a -2, so I'm going to write down +2. Whatever's outside the parentheses, just copy that down. So to me, obviously -3, so I'm just copying that. So I'm making extra work for myself, but 2, -3 should be my vertex. So all we're going to do, go to your graph, find the point, go over 2, down 3. Okay, now if you remember this from yesterday, just kind of ignore me and go ahead and graph it. If you weren't here yesterday, the way the pattern works is from the vertex, you're going to go over 1, and then you're going to go up or down the pattern. In this case, we're going up. So just from that vertex, go over 1, up 1 on either side. And then from there, it's always over 1. Then I'm going to go up 3. And then I'm going to go over 1. I think these will all fit. Up 5. You really only need 5 points to graph, so I'm going to go over 1, up 3 from where I was just at, and then this should fit on here. I'm going to go over 1, up 5, and then just go back and do your best to make a U shape. Don't make it pointed at the bottom. That's what we have for absolute value, but for a quadratic, it should be curved. But that's what when I say the pattern, it's always over 1 and then up or down the pattern. We'll do another example next to this that'll go down. Yes.
So I feel like yesterday we were doing it different. How did you get the H and K?
So yesterday we didn't have any parentheses. So yesterday, here I'll just flip this back over. Okay, so like I'll tell you what. Let me write this in vertex form. So this would be written like x minus 0 squared minus 4. It's just if I have 0 as my x coordinate, x minus 0 would just be x, right? So instead of writing that little set of parentheses, they just write x squared.
So whenever there's an x in the parentheses, we just use the number outside.
The number outside is going to be your y coordinate. The number inside is going to be your x coordinate. So there's nothing inside, like there's no parentheses, so that's why the x coordinate was 0. Whereas if I flip this over here back for today, now there's something inside with the x. So that that moves the graph. And the reason it's the opposite, it's whatever would set this equal to 0. So like if I plugged in 2, that would set that equal to 0, and that's where you switch from one side of the U to the other. So that's why it's the opposite of what it looks like, because it's what sets it up to 0. Whatever's outside just literally moves it up and down, just exactly the way that you think it would. Like if it's -3, we're going to go down 3. So when I read this, this is going to go right 2, down 3. So from the origin, I go right 2, down 3. That's how it shifts it, and then all the other points would move that way too. So that's why you can use that pattern.
I have one more question.
Yeah.
So if it's like 3x, do we use the number inside, or we can use the number outside? Like, yeah.
For the pattern?
Yeah.
Whatever's in front of the parentheses, that's what you're going to use for your pattern. Nothing inside the parentheses. That's a really good question. Really good question. So let me do domain and range, and then we'll do this next one here real quick. Okay, domain, no matter what, is how the graph moves left and right. And I know these guys go up really fast, but this side goes left forever, this goes right forever. No matter what parabola you are working with, the domain should be -infinity to infinity. One side goes left forever, one side goes right forever, so you'd cover the whole x-axis. It looks like it does go up really fast, but it does go out as well. The range is the one you got to look for. So the range, like I'm not touching any part of this graph, right, until I get to the vertex. And the range has to talk about the y-coordinates. It should just be, this is the first point I touch, you're going to grab the y-coordinate of that point, which would just be -3. It should just be the y-coordinate of the vertex. And then everything else just goes up forever. So it's going to go up to +infinity. So we'll try one right next to this. Okay, now, do you guys see how there's like a little negative out in front of the parentheses? So in this case, my a is -1. So all that's going to do is it's going to make that pattern negative. So it would be -1, -3, -5. Anybody want to try the vertex for that second example? What do you think? Perfect. -4, 6. So to me, like that looks like a +4, so it's the opposite in the parentheses. It's what sets it equal to 0. Outside the parentheses, just copy that. That'll be your y-coordinate. So let's go over, so we're going to go left 4 and up 6 from the origin. Okay, now for my pattern here, it's always, I promise you, over 1, but because of that negative, we're just going to go down 1, and then I'm going to go over 1, down 3, and then if I can fit it, over 1, down 5. So over 1, down 1 on either side, then over 1, you're going to go down 3. Remember, if you're working with a parabola, it's not consistent between like a slope. It's like over 1, and then it'll be down a different amount or up a different amount every time. And then I think we can fit this on here, down 5. And then I'm just going to do my best to make that a curved, like an upside down U shape. To write my domain, no matter what, I know it's going down, but one end, like this end's going left forever, this end is eventually going to go right forever. So no matter what, any parabola, if they ever ask you for the domain, it should be from -infinity to infinity. It'll cover all the x values. The range here is weird. So this is going down forever, right? So when you write your interval, you got to start with the lowest possible y value for the range. So that's pointed down to -infinity. This one would stop when you get to that vertex right there. So I'm just going to grab that y-coordinate, which is 6, and I would have a bracket. Basically what that's saying is all the y values are below, they're 6 and below, and that's true. There's nothing above 6 on that graph for a y value. Is anybody having a question? Okay, so this is just a general form, so I'm going to write down some information for you about, I don't have any numbers in here. This is just your vertex form. Okay, the vertex is the HK. The way that formula is, you can see it's x minus h, so it's kind of saying the opposite of what it looks like when you write that down. And Okay, I'm going to draw like a tiny little parabola. So it depends on which direction the parabola turns. If you have a maximum value, it's just going to be a y-coordinate, but it depends on how the graph turns. If it turns upside down, that'll have a maximum. If the graph turns right side up, vertex is going to be the minimum, and it's just the y-coordinate of the vertex would be that value, and so that should just be k if you have that equation. Axis of symmetry, if you guys remember from yesterday, goes right through the middle of your parabola. It's always a vertical line, call it vertexal to help me remember, and it has to go through the vertex, so it should just be x equals whatever the x coordinate of the vertex is. If you have vertex form, it should just be that h value. Horizontal translation is going to be, horizontal goes left or right, and this should be h. The vertical translation, that would mean up or down, and that's going to be k. So the h moves the graph left or right, opposite way that you think. The k moves the graph up or down, exactly the way that you think. And then we haven't done anything with these yet, but we will in the next example. So you can have a stretch or a shrink. I'm going to just jot this down real quick for you. If in front of the parentheses you don't have anything, so it would just be 1, or if you just have a negative 1 right in front of the parentheses, you have no stretch or shrink. Those are just considered, the negative just flips the graph over, but in terms of like the width of how big the u is, it's the same either way. So there's no stretch or shrink if you don't have like a number in front. If you guys, here, let me slide this up just a little bit. If you look down to my next example, like I have a 1/2 in front of the parentheses, then you have a stretch or a shrink. If I have like a 2 in front of the parentheses, then I have a stretch or a shrink. And that's what these numbers are. And it does say that you can ignore whether the a value is positive or negative. The positive just goes right side up, negative makes it go upside down, but it doesn't affect the width of the graph. So if we ignore the negative, if we have a number like 2, 3, 4, that is called a stretch. And a stretch is going to make your U shape, literally like stretch it, make it more narrow. If the number, we're going to do this in the next example, it's like a 1/2 or 2/3 or something like that, that is going to be a shrink. And that makes the graph wider, or they say it's like compressed sometimes, but it'll be like a wider U shape than if we just do the 1, 3, 5. Okay, now domain. I told you this on the first couple questions. Absolutely no matter what, for any parabola, whether it turns right side up or upside down, it's going to be negative infinity to infinity. Okay, I'm going to use 2 different colors here. So if the graph goes right side up, okay, if it goes right side up, your range will start with the y-coordinate of the vertex, which is k, in that vertex form, and then it goes up forever, and so it'll go to positive infinity. If your graph, sorry, I should have given a little bit more space. If your graph goes upside down, though, that's the reverse. So that interval would start with negative infinity, and it would stop at the y-coordinate of your vertex, which would be k. So if you want to pull this down a little tiny bit. If you look at these 2 examples above here, this first one went right side up. So the range was just y-coordinate of the vertex to positive infinity. If you look at this graph, this one turned upside down and it was negative infinity, and it stopped at the y-coordinate of the vertex. So it does depend on which way the graph turns, but domain is always negative infinity to infinity. Range should involve the y-coordinate of the vertex. If it goes up, y-coordinate of vertex to infinity. If it turns upside down, negative infinity, and it stops at the y-coordinate of that vertex. Okay, so let's try, we're just going to go through here and see if we can graph this. I have just y equals x squared on the graph so you can kind of see the comparison for all the transformations we're going to do. So, can anybody look at this lovely equation and tell me what they think the vertex would be of my new graph? If I do 1/2, I've got x plus 6 squared minus 8. What would the vertex be?
0, 0.
Not 0, 0. What were you going to say? -6, -8. Okay, now the graph that's on here is 0, 0 because it's just plain x squared, so that's like your parent function. We're just doing this so we can compare them. All right, now because of the way this is positive 1/2, so I know the graph is going to turn right side up, so that'll be a minimum value. Minimum value, and that'll just be the y-coordinate of the vertex, which is -8. All right, for your pattern here, remember, if you have a number, like my little number in front of the parentheses, a is 1/2. All right, so if you have an a value, you just multiply that by the 135, and I was asking you guys yesterday, please, 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 if it's a fraction, write your pattern as decimals, and I'll go through that here real quick. But if I do 1/2 times 1, it's 0.5. If you do 1/2 times 3, it's 1.5. And if you do 1/2 times 5, you get 2.5. So I'm just doing three spaces. We could keep going with that pattern, but 135 should give you enough to get the graph. Axis of symmetry should go right through the center of the parabola, so it has to go through the vertex. So it's always just x equals a number, and that number should be the x-coordinate of the vertex. So it'll be -6 for this graph. And then this one, because that a value, it's not negative here, but if it was, I would ignore that. If that number is between 0 and 1, which it is, that is considered a shrink. So it's going to be wider. And I can do this without even graphing it. Domain, no matter what, any parabola should be -infinity to infinity. And let me go ahead and put this on the graph so I can see this before I do the range. So we're going to go to -6, -8. So I'm going left 6, down 8. Okay, now the way your pattern would work, and you don't have to write this out, but from there I'm going to go over 1 and then I'm going to go up 1/2. So we'll just have to estimate. So just kind of like halfway on the lovely grid mark. Then I'm going to go over 1, up 1.5. That should actually put you on a nice point. So you're over 1 on the halfway mark, up 1.5 should put you, let's see, this is -4, -6 if you're on the right side, and it'll be -8, -6 if you're on the left side. And if you want to go one more, we should have plenty of space. I go over 1, up 2.5, and just estimate. So I'm going to go over 1, count up 2, and then kind of go halfway. Over 1, up 2, kind of halfway. And then that way you guys will be able to compare this. Do you see how this is wider than just the x squared graph that's on there? So it's like the U shape is going out wider and it's scooched over 6 spots to the left and 8 units down, and then the graph is basically compressed and it's wider. In terms of your range here, based on what I told you up here, it should just be the y-coordinate of the vertex, which it is. So the first point you touch would be the vertex there. And y-coordinate of that point is -8. And then the rest of the graph is just going up forever. So it would go up to positive infinity. Does anybody have a question? Okay, I'm just going to run you guys through 2 more graphs that have like a stretch or a shrink on them. Alright, so I have some kind of giant graphs on the back, forgive. Alright, I've got, this one says y equals 2, and then I got x plus 1 squared minus 6. Who could just raise your hand and tell me, like, what would the vertex be here? If I did my opposite copy, what would it be? Perfect, -1, -6. Okay, now, here's your pattern. So the a value is 2. So for my pattern, and you'll get used to these once we've done these a couple of times, but I know I'm going to multiply my 135 pattern. I'm going to take and multiply each of those perfect squares by 2, so that's going to stretch that pattern out. So this would be 2, 6, 10. You only have to graph 5 points, so if we don't have enough space to go up 10 spots, that's fine. We should have enough on the graph here to do this. Axis of symmetry. X equals whatever the x-coordinate of the vertex is, which is -1. So I'll draw that on this graph. You should be able to tell from the equation whether it turns right side up or upside down. Since my a value is +2, I know that it's going to go right side up. So that graph would have a minimum value. And it should just be whatever the y-coordinate of the vertexes, which is going to be -6 here. And then for my domain, no matter what, -infinity to infinity. I'm going to save the range for a second. Horizontal translation, so that would be left or right. So that's going to go with the x-coordinate of the vertex, which is -1. So from the origin, this is going to go left 1. Vertical translation is how you move up or down, so that's going to go with the y-coordinate of the vertex. So this would just be down 6. And then in terms of stretch or shrink, or neither, in this case we do have a stretch because that a value is 2. If that a value was 1, then we would not have a stretch or a shrink. Okay, I'm going to leave the range so we can put this on the graph. So we're going to graph, go over 1 to the left, down 6. And then for my pattern, I'm going to go over 1, up 2, over 1, up 6. I don't think it's going to fit, but I could go over 1, up 10. So just from the vertex, I'm going to go over 1, but we're going to go up 2 spots. So it should be more narrow. Then I'm going to go over 1, and I'm going to count up 6 on either side. And yeah, this graph is not tall enough to go up 10 spots, but this is totally fine. There's plenty of points to get a good idea of that graph. Your range, you don't touch any part of that graph till you get to that -6. So it's bracket -6, and then it goes up forever to positive infinity. So we're just going through here and kind of doing a description of what we got going on. Okay, now I got one more. All right, now that negative out in front immediately tells me the graph is what, right side up or upside down? Upside down, immediately. And because it's a half, I know it's going to be like a little bit wider, but immediately I know the graph should go upside down. What should my vertex be for this second example here on the back? 3, 7, excellent. So positive 3, 7. Opposite inside the parentheses, copy what's outside. Okay, now the pattern here. So I'm going to do -1/2 times that 135, but please, 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 if it's a fraction, just write it as a decimal for me, because sometimes people try to use, if they see a fraction, they'll do like rise over run, and you do not want to do that here. So I'm going to write -1/2, -1.5, and -2.5 would be my pattern. All right. Here, I tell you what, actually, let me go back. I'm going to sketch in the axis of symmetry here on this last graph. Should just go right through the middle. In that previous question, it was x equals -1. In this question that we're going to do down here at the bottom, and I'll sketch it in this time and not forget, should be x equals the x-coordinate of the vertex, which is 3. So I'm going to just come over here. I'm going to draw a little dotted line through the 3. And then our parabola should be symmetrical on either side of that line when we actually draw it. Now, because the graph we know turns upside down, that's how I know that I'm going to have a maximum value. So maximum value for this one should just be the y-coordinate of the vertex. No matter what, -infinity to infinity is your domain. My range, let me put it on the graph and then we'll figure that out. Now, horizontal translation. This is going to go with your x-coordinate of the vertex. So if it's 3, that's right 3. The vertical translation goes with the y-coordinate of the vertex, which is 7. So if it's +7, it's going to shift the graph up 7. So from the origin, you're going to go right 3, up 7 to plot that vertex. And then this guy is going to be a shrink. The a value, it doesn't matter whether it's positive or negative, but the fact that it's a half, it's between 0 and 1, is going to make it a shrink. Okay, so go find this point, so 3, 7. All right, now for the pattern here, I'm going to go over 1, but I'm going to go down and just estimate a half. So like on the halfway mark. Then I'm going to go over 1, and then I'm going to go down 1.5, which should put me on a nice point. So on the halfway mark, I'm going over 1, down 1.5, puts me on the point, let's see, 1.5. If you go on the other side, the right side, it should be over 1, down 1.5. That is 5.5. And then you should be able to fit this if you want to. Over 1, and then I'm going to go down 2.5, just to estimate here. Over 1 down, 2.5, over 1 down, 2.5, and then just doing my best to kind of create that U shape. And you'll see I drew the axis of symmetry on that one, but if I folded the graph on that line, the two sides, if I had drawn it perfectly, should match up. Is anybody having a question? Yes. Oh, so I forgot. Okay, good. We'll go back and do the range. Fail. All right, so this would go down forever. So for the range, I'm going to go negative infinity, and then we would continue to trace the graph up. You would stop touching that parabola at that vertex. So the highest point for the y values would be 7. So we'd have a bracket with that. It should just be the y coordinate of the vertex. I almost forgot. Okay, does anybody else have a question? Did I screw something up?